Let's learn about HashMap internals, how it is implemented as part of this session. So HashMap is a collection based on map and consists of key value pairs. Here is the brief overview of the implementation of HashMap. Basically, when you want to implement a good HashMap, you need to find the good hash function. That is the first step. So to define the hash function that converts a key into an index in the hash table. Build a good hash function to generate a hash value. So the key you can give to the hash function will generate a hash value for that. Hash table. The hash table is a dynamically allocated array of buckets that stores the key value pair. Each bucket is a linked list of nodes that hold the key value pairs. The number of buckets is determined by the container's load factor, which is a measure of how full the hash table can get before it need to be resized. So insertion, when a new key value pair is inserted into the hash map, the hash function is used to compute the index of the bucket where the pair should be stored. If the bucket is empty, a new node is created and the pair is stored in the node. If the bucket is not empty, a linear search is performed through the linked list to find the node with the same key. If the matching node is found, the value is updated. Otherwise, the new node is created and inserted at the end of the linked list. Okay. And also you can see the collisions basically. If there is any collision, and then you are going to create a new node from there. Retrieval. When a value is retrieved from the hash function using a key, the hash function is used to compute the index of the bucket where the key should be stored. A linear search is then performed through the linked list in the bucket to find the node with the matching key. If the matching node is found, the corresponding value is returned. Otherwise, an exception is thrown. Deletion. When a key value pair is deleted from the hash map, the hash function is used to compute the index of the bucket where the key should be stored. A linear search is then performed through the linked list in the bucket to find the node with the matching key. If the matching node is found, then it is removed from the linked list. Otherwise, nothing is done. And overall, hash map provides a flexible and efficient with a constant average time complexity for insertion, retrieval, and deletion. However, choosing an appropriate hash function and load factor is important to ensure good performance and avoid collisions. Okay, let us see like some coding part using C++. Okay, let's start coding part. We can include IO stream for any output or input output purpose. We need a list, so just include list, also include some string. To avoid like every place to add std, we can write nameset std for that. So before going to start, let's define what kind of key value pair we need to take it here. Let us use the template of type name, probably key, and another type name will be kind of value, right? You can write struct of type pair, okay, which has key of type key, v of type value, okay. So now you have key and value pairs. Now let us write a one hash function which will return a hash value, and it will take a currently will take as a string actually of type key basically. So from which what we can do is we can create a hash for that particular key. Okay. For character C, we can just walk through the key, each character, and here hash equal to hash into 26. We'll use some kind of constant here, and we'll add the all characters to it. Once hash is completed, we will return that particular hash as part of this method. So we are ready with basic some hash function, right? Perfect. Now let's write a hash class. So before going to that, we'll again use the template of type name key, type name value, right? Can as we can use the class HashMap. So here what we will do is we'll use the private section. In the private, what we can do is we can define size actually, HashMap size. Basically, we'll make it as 100 for now. And let us create a list of like a pair of key value. This is the hash table of whatever size we are getting now, right? Okay. So we have some private section here. Good. Let us do public section. Now what we will do is we will try to write a insert method which will take key and v of value, right? And which will try to insert it. So here what we can do is we are trying to create a hash, basically get the hash value for that. So we can say it as an index that equal to hash function. Let us pass the key for that, and that key range should be like within our hash table size. Our size is just 100, right? So just mod of 100 if you do, you will get the value of hash value less than 100 always. Once you are done with this, just check um, we need to insert it, right? Okay, okay. So what we can do here is we will try to we'll just travels to the table with this index. Okay, okay. So check like if pair dot key equal to key, then what we can do is we just update the value. That's it. You are done here. Okay. Suppose you are not able to find this the same key here, then what we need to do is table of index dot pushback of that key and value, right? That's it. We are ready with the insertion. Let us get the value. The value is of type basically v, right? Let us get. We can take here key. Okay. So again here we need to find we need to compute the index using hash function. Again we need to do the mod size of the table. Now you got it. Now let us try to get this one. uh, table of index, right? So if dot key equal to key, then what we need to you need just return pair dot value. Okay. For example, if you are not able to find this one, then throw exception. Invalid argument and you just key not found, right? This is the insertion and this is the basically insertion and get it. Let us remove actually removal or delete. Remove also we will take the key. Here again we need to calculate the index. Basically index equal to hash function of key mod size. Okay. Oops. So once you got this index, then what we can do is we can just try to table of index dot begin is not equal to attend to plus plus. Just iterate uh, over the table, actually tables, so that bucket list, linked list. See if key equal to key. If this is the case, then you found that one. Now what you can do is index erase this particular item and return. If you are not able to find any key here, just you no need to do anything basically. Okay. Let us come back to main function. Now what we can do is we can create a hash map of type string and integer, right? Of type probably hash map hm dot insert. Let us take some name. I will take my name here, some value here. Okay. So what we will do is we'll try to read this value. Let us see with some base thing. Gem dot get. So we are expecting here to print 1230, right? Okay. So let us compile and see what happens to this program. Mm, mm, mm. It compiled successfully. Let us run it. Yeah, you are able to get the value of insertion. And let us insert some more values. I will use something called I will use some kind of 1 2 3 4 for digital. Okay, what we can do is we can try to read these values, right? Let us build this, right? We are able to read all the values. Let us delete one value now. Let us remove of key digital basically. If you read that again, we should expect some exception, right? Let us see how it works now. When I call last one digital, right? Okay, let me bring this. Yeah, if you see that terminated call after instance invalid argument key not found, right? After deleting this, after removing this particular digital key, we are trying to access this, that is returning actually exception. That's it about like internal implementation of this hash map. And by using hash function, we can keep generating hash, and then we can go ahead and insert the elements in the right place.